this is Ms. Erickson, and today we're going to do the cut short demo. So open up your packet to the page that says cut short demo, and when you're ready, press play. So here we have a pendulum. I set it up. I did 1 and 2, and we're almost ready for 3. So a pendulum is this string. I've got washers that acts as my weight, and if I pull the pendulum back, it swings back and forth and back and forth. And you can see if I pull it to the height of the table here, I'm using the table as just a reference for how high I pulled it up. When it swings over to the other side, it swings up to about the same height. So this is a good example of conservation of energy. It starts with potential energy because it's up higher, and the higher I pull it, the more potential energy it has. And then it turns to kinetic energy on the way down, so it's swinging faster, and then back to potential, kinetic, potential, kinetic, potential, kinetic, potential, kinetic, and it just swings back and forth like that. Yeah, I've added this rod that sticks out here so that when it swings, it's gonna swing like that. And then the other piece that we have back here, this string here, which is, I know it's a little bit hard to see, so I added these flags to make it hopefully a little bit easier to see, but there's a string in the background here. That string in the background just marks the height where this rod is. So I'm going to pull it back to about the height of the string, and then you need to make a prediction. So I'm going to let it go, and then that's the picture you can see. I'm doing the picture on the side here in figure A. I'm going to let it go. It's going to swing down, and when it swings up, the question is it going to swing lower than this string? Is it going to stop somewhere here? Is it going to swing to the height of this string, or is it going to swing higher than this string? So you have to pause and make a prediction, and you don't have to come up with a number. The question is, if I start it at the height of this string here, when it hits this rod and it comes back up, is it going to end? Is it going to stop lower, at the same height, or above? And if it's close, we're going to say it's the same height. So it might be just a little under, a little over if it's the same height. But if it's lower, the same height, or above. So pause, make your prediction, and then let's try it out. All right? And we're going to try and get the same height. So I'm going to try and eyeball it here and see that it's the height of the string. And it's pretty bouncy, so the last couple ones might not be the right height, and then it gets all messed up when it starts moving around a bunch, but we're going to try and make sure that everything is straight here. And we'll do it one more time. And so we're really trying to focus on the string. So it's at the height of the string, and then what height does it get to on this side? Four and 5. 4 was your prediction, 5 was your actual observation, and we saw it did go back to the height of the string on this side. For 6, now we're going to move the rod higher than the string. So we're going to move the rod up here, and then similarly, you're going to make a prediction. So I'm going to do the same thing. I'm going to try and release it from the height of the string, and then your prediction on this side, is it going to be lower, the same height, or higher? So pause, make your prediction for number 6, and then the observation we'll do when you're ready to press play. All right, so we're going to do the same height again, and then we're looking to see what height does it get to on this side. Looks to be about the same height again. So when I release it this high on this side, it goes to the same height on this side, and that can be explained using conservation of energy. Whatever potential energy it has, it went to kinetic, and then back to potential. It got back to the same height because it had the same potential energy. All right, number 7, what would happen if the rod were attached lower than the string? So we're going to try that next. Rod is lower than the string. Here's the string height, here's the rod height. I'm going to make it just a little lower here. So I'm going to do the same thing. I'm going to release it from the height of the string, and then you're making your prediction. Is it going to end below, at, or above. So make sure you have a prediction in 7. If you don't have a prediction, press pause. And then we're going to go to the same height again. And this one, we only get one trial to see, because then once it starts bouncing, it loses a lot of energy to the bounce and the friction. So make sure it's straight. Try it again. Oh, I think I put my head in the way. One more time. So once it starts bouncing around, there's a lot of friction. It's going to lose a lot of energy. But before it loses that energy to friction, the first time it comes up, it should go to that same height again. And then write down your observation and press pause and take a minute to think about the analysis and write down some answers for your analysis. And when you have your answers, come back for just a minute. About number 1, so conservation of energy. What kind of energy does it start with? What kind of energy does it have here? What kind of energy does it have here? That's what you want to think about when you're answering number 1 of the analysis. Number 2, is there an upper limit for how high the rod can be? Let's try really high. Nope, no upper limit. Let's try really low. Is there a lower limit? Let's see if we can. I'll try it from this side. I think it'll work better on this side. So we're getting some, oh, here. This is what, there we go. That's what I was waiting to see. So it can't go to the same height. Yeah, that was a good one. Because it can't get tall enough. So there is a lower limit where it won't go to that same height again. If you bring it up here, it can't make it to that same height, but it's going to keep going. It still has kinetic energy. So when it reaches the top, it's gotten as high as it can get because of the limit of how tall the string is. And since it still has kinetic energy, that's what makes it keep going. So when it still has kinetic energy, that's when it loops over. All right, make sure you have answers to all of your questions. Make sure you've looked at the analysis and you've thought about conservation of energy and how conservation of energy relates to all of these. And you, once you have all of your answers, you are good with your cut short demo.